Hi everyone, Dex here from RegTech, and thanks for joining us for today's webinar, 3 ways connecting 2D and 3D CAD helps you design faster. So we will have Thomas Club from TechNexus presenting for us. So just a quick introduction about RegTech. So we're a leading provider of design technology and services to engineering and architecture professionals. With over 20 years of local experience, we provide the expertise, training, and support to help companies realize the full potential of the design technology. The RegTech mission is to deliver industry-leading services to the engineering, construction, and architecture communities. We work with clients and companies of any size nationally and abroad. Over to you, Tom.
Thanks, Dexter, and thanks to everyone joining us on the call today. I guess before I kick off, I just wanted to have a bit of a sort of a brief overview of myself. I've been in sort of, I guess, CAD, drafting, BIM industry for probably pushing 25 years now. Ex-Worley Parsons, ex-GHD. I'm an ex-Autodesk employee as well. I finished up at Autodesk late last year and then basically ended up doing contracting work. But I do have experience right back through to the early days of drafting. I started out on the drafting board, so I'm aware of the initial I guess industry standard that was with the board, and then eventually moving into things like CAD, even just in a 2D sense, and then slowly moving into 3D, and then obviously into sort of more BIM kind of projects. Now, I guess let me just go to the next screen. Sort of some of the questions or answers I guess that people come up with staying in 2D, and one of them that I have come across a lot is that people are generally quicker in 2D, which is a fair comment. If you've been doing AutoCAD for the last, even if it's 5, 10, 15, even 20 years, that you might have macros sorted, you might have your routine sorted, and you can sort of knock out, be it a house plan, be it steel details, and whatever else on AutoCAD. So that's one thing that we have, for people staying on 2D. The other one is cheaper. So your subscription to an AutoCAD is cheaper than going to something like an AEC collection or a product collection, where you do get the tools like Revit and Inventor and Fusion and all of that kind of stuff. But generally, sometimes people don't see the longer term issue where, rework and be it even sort of human mistakes made with sort of missing out on some details on a drawing as well. So again, you sort of have to have a think about sort of the overall system when you're pricing up a job. Would it be better to move into something like 3D and get the documentation out from that, and then when you do make a change to the model, that obviously all the documents and everything else flows on from that. Like I mentioned before, if you have been using AutoCAD, it's just a common sort of thing that people just say it's just always how we've always done it. It might be even just someone's personal preference just to stay with AutoCAD. So again, have those discussions with people and try and see the benefits of moving into something like a 3D platform. To get out of, I guess maybe that we can call it a rut of just sort of sitting in 2D and not sort of moving forward with the times as well. And then one of the other comments that comes up as well, that customers just sort of want it that way. So you're issuing a PDF or even a DWF file. And I'm working with customers now who are basically saying that they will not issue 2D until sort of more the very end. So they utilize Navisworks a lot. And then that way comments are done inside the Navisworks file, and visually it's a lot better medium than it is to sort of be looking at a 2D where things can be missed and not picked up. And then some of the labels about 3D. 3D is expensive. Yes, it can be. But from the word go, it might be. But then, once you do have things like advanced steel templates or Plant 3D catalogs and specs or Revit families, then that cost is could be great at the beginning of the project or the beginning of your transition to go into 3D, but then eventually that cost will be negligible because those catalogs, those libraries, those families, those settings are already done. So you just need to basically redo files or models or whatever it might be that you're working through. Also, as well, is when you are transitioning from 2D to 3D, look at it as a bit of a long term. Don't just jump into it on Monday and say we're going to do 3D straight away. In particular, companies like home builders, if they're going from an AutoCAD to a Revit, then you might sort of say that's it could be a few months and maybe even possibly up to a year of just transitioning. So you're not having your staff just basically jump into 3D and their productivity be zero if they're not aware of working in 3D. So you might nominate 1 or 2 people and then slowly convert the whole company over from 2D to 3D. BIM is a buzzword. Again, that's just not the right thing to think. It is here. It is here to stay. The tools are available to it. There are places around the world that are mandating it. If you are following it within Australia, there is talk of Australia mandating it, but again, you look at overseas countries where they have done it. So for government projects, they're basically saying you have to do it in BIM or you don't get the project as well. So that's another thing. You don't want to be left behind, I guess, and be doing all of your transitioning from 2D to 3D on the very last day. You want to be looking at it now, and then slowly, work yourself for the next few months, and like I said, up to a year or even longer, just to get yourself into that mindset. Customers don't care for it. I think that's more so a little bit of education as well, and maybe they're not aware of it because, for previous years, they would have just received PDFs all the time, and that's all they're used to. And if they're not aware of having the ability to be given a 3D model, they might just write it off. So have those discussions with your clients and have a talk about, would a 3D model make life easier? Would even eventually, not tomorrow, but in the next few months or year or so, have a talk about, would something like virtual reality also help with making decisions on the design or, anything to do with that model? VR can be very, very helpful in that. And I personally have had experiences where showing a Revit file in Navisworks was good, but then when they put the VR headset on, they picked up that there was an issue with one of the air conditioning units up on the roof. So again, have a talk with those people, and if you need to obviously adapt or upskill, then obviously start that process. And this is another one that I said before, with 2D is how we've always done it, and then with the 3D is expensive. Again, that's I think a misconception. It's always going to be expensive and it's always going to be hard to learn. I personally, I'm doing projects now where I can knock out a steel structure that I did as a demo for a client. They were doing it in Inventor and it took them days to do, and I did the exact same project and I did it in 10 minutes with documentation. So once you do, it's kind of, maybe even thinking back to the old drafting board and going into CAD days, that, some of these comments were, existed 20 years ago when people wanted to transition from the drawing board to CAD. And then, that initial cost it might be great, but then eventually you will save further down the track when you can start producing models and documentation and a bill of materials in even half the time. It's still going to save you time and money eventually anyway. So working within 3D, so you can see there we've got our building there, and basically this isn't everything that you're going to get out of 3D, but this is just a few bullet points as well. So 2D documentation, it's pretty much, with most of the products, just sort of a click of a button, setting up of a view, and then the 2D representation is taken from the 3D model. So In Revit, for example, if I move a wall, then the sheet and its view is updated. So all I need to do is just go back and make sure that annotation has moved or needs to move or needs to be updated, and then I can just print off the drawing. Same thing goes for Advanced Steel and for Fusion, which we'll go through after this portion of the slides. We update the model, and then in Advanced Steel, the document manager in there tells us that the drawings need to be updated, and then that way we can determine if they need to be updated or even need to be up-revved. And the same thing goes for Fusion. As soon as I edit the model, then the views on the associated drawing change. A big one on the left-hand side there, the BOMs, the bill of materials. There's a few words for these sort of BOMs, material takeoff, schedules, quantities, all of those kind of words. So again, depending on the discipline that you're doing and how you're working, you can, again, in Revit, click a button and it'll tell you how many windows there are in something like Plant 3D. So for any of the pipers on the call, we click a button and it tells us that we've got 52 long radius elbows in there as well that we need, and we need 4,000 bolts. So again, all of those are pretty much just a click of a button because they have been modeled, and you will determine through the course of the project what kind of level of detail as well. So whether you're doing just the walls and windows, or whether you want to drill down and get right into the nitty gritty and do the screws and hinges on doors inside Revit if you really wanted to. But again, the ability just to click a button and get some quantities out is a huge benefit. Clash and collaboration kind of tie in together there. So clash on the left and collaboration on the right. So, you know, architects working with services companies, working with steel detailers, working with the civil group. We can use Navisworks to combine all of those models together and then find a clash. And I've got an image of one that I'll show a little bit later in this presentation. And it just gives you the ability to utilize Navisworks and to pick up those clashes before anything happens out on site. So you don't want to end up sending someone out on site with a gas axe just to cut a steel beam just because the cable tray or the ductwork was in the way. You want to find all of those issues before anything happens out on site, before steel work goes to a workshop to be cut and welded and whatever else it needs to do. So you want to find all of those in the digital model before you send anything out. We'll go back up to the top up there in the yellow balloon there, visualization. So even from a marketing standpoint or for your website, or, you know, to demonstrate to the client that we can show that building in 3D, we can apply materials to it. So you can see there that we've got some brickwork in there, we've got some concrete. So again, it's just one of those things that because we've modeled it and you know, we have taken care of all of those details, the visualization is sort of a given at the end of the day. And then subsequently, if you are using something like the AEC collections, then we can bring our models into 3ds Max and apply some more real world lighting and materials and textures and that sort of stuff as well. Contingency, that's always something on projects that needs to be taken care of. You know, you might be nominating a high number for the contingency, but if you're doing something like a 3D model of a steel structure in Advanced Steel, for example, you know that there are, you know, we have modeled all of these connections, and we know that we have 500 bolts to buy. So your contingency might even be less. And then that way people out on site aren't just digging a hole and burying all the bolts as they might have done in the past where there were too many bolts purchased for the project. So again, have a think about the contingency, and you might even just say that there's, as a better number, it might be 2% or 5% just for a number instead of being 20%. And then lastly, down the bottom, so 4D and 5D. So in sort of the project terms, 4D is time. So inside Navisworks, we can use the timeliner function to build the project and connect it to Microsoft Project or Primavera charts in there as well, and we can assign elements to those dates and times and slowly build it. And then also 5D, we can associate cost with these elements too. So if you have a bit of a Google, a bit of a play around, you can see that 5D is mentioned in some places where it's the 3D plus the 4D equals the 5D, or 3D plus 4D plus cost equals the 5D. So there's some of the benefits that you're going to see with jumping to a 3D platform. Now today I'm going to focus on manufacturing and the AEC customers, and you might see that, you know, in the past it would have been drawn, you know, on the left hand side there, the manufacturing just would have drawn up the element from one side, and then you would project lines over to the right and create a section for it. And then on the right hand side image there, that's just an old house plan that was drawn by hand, and you know, any manual takeoffs would be done manually. You'd have someone sitting there with a marker or a pen and counting how many doors and how many windows and what kind of windows. So, you know, and all of those sections that you can see there on the right hand side all would have been done by hand, by either projecting lines or measuring from one side and drawing lines across to the other. So it's not to say that it wasn't a bad way of doing things, it was just what was available to us at that point in time in life. And here's an image of a model that was done in a program called Infraworks. So for anyone on the call today that deals more with the civil side of things, you can use Infraworks to model up your conceptual idea of a road and a bridge that we have here in this model. We've placed some trees and some cars, and for visualization purposes, this is your design intent. With Infraworks and Civil 3D, we can use Civil 3D to import the Infraworks model, so all of the surfaces that are existing, plus all the surfaces that are proposed will come over. The road alignments will come over, roundabouts will come over, bridges will come over, and then that way your Civil 3D model is already, you know, in milestone terms, it's probably already 10 or 20% done instead of starting from a 0 point. So for all the civil people on the call, have a look at using Infraworks and Civil 3D to generate some of these models. This is a 3D model of a valve that I did in Fusion that was converted from 2D to 3D, so you can do that, and that is something that we will cover in the session in a few minutes. I will actually load up Infraworks and show you how that was done as well. But again, I've got a rendered model there of a cast iron valve. I don't have the bolt details on the flange just yet, but again, it is something that once I model it, then the 2D documentation for that comes out for free, basically. And then for the pipers on the call, as I mentioned before, if you're using Plant 3D, we can link up all the piping equipment, structural and MEP models all together. And then subsequently, why we bring it into Navisworks is doing things like a clash. So you can see here that we found a clash in that piping model. It's a piping elbow that's clashing with a steel beam there, and then from that we can determine through you know, meetings or discussions, just going up and tapping someone on the shoulder, do we need to move that elbow out of the way, up or down, or do we need to move that steel beam? So again, these decisions can be made before anything happens out on site, whereas if we weren't using Navisworks and we didn't pick up this clash before we went out on site, you might end up with a hefty bill at the end of the day, trying to get someone out there with a gas axe to cut and shut bits and pieces. So excuse me. So let's jump into a live demo now. So as I mentioned before, Fusion is one of the tools where if you already have items in 2D, we can go to 3D, you know, pretty much straight away. So I've brought in just a 2D drawing of a lever. Now, using some of the tools in Fusion, I can extrude this, and then I can say that let's make it a 5mm thickness in here, and I can nominate you know, directions, whether it's one side, both side, and it's a new body. And now that we've got it in there, we have a 3D model of this as well. There is also, you know, if there is a need to do simulation in here, so I can put loads on this, and then that way Fusion will give me you know, I guess the strengths and the weaknesses of this part depending on the loads and depending on what I need to do. So plus as well, also I can just as easily come in here and put a fillet on this, so I don't need to play around with sort of 2D drawings, and then I can just use the functions here. I can type in a value of 5, and you can see that automatically that has filleted around there. And then again, I don't need to play around with any of 2D drawings. I don't need to worry about what's happening with other views. So I'll just do the same for this other side, and I'll type in 5, and then I'll do another one again just in here as well. So I'll put a fillet in here and make that 5 millimeters. And you can see how quick and easy that is to generate and to produce, and then subsequently we can make a drawing out of that as well. So I'm just going to close this one off. And then this is, again, a similar sort of thing. I've got a 2D section of an object, and we need to revolve it. So under the Create tab, I'm just going to go Revolve, pick the region that I need to do. And then, actually, before I do that, I just need to do a sketch line. So I need to put a axis. So I just need to draw a line through here, stop the sketch, and then before I go, and then I need to jump into the revolve, and then what the axis is, and then you can see there that we do have our 3D model of this bottom plate as well. So subsequently we can make a drawing out of that. And to show you that, I'm just going to save this, and then you can see here new drawing from design, and I'm going to put it on an A2 sheet. And then Fusion's going to ask me where the views, so what the base view is, and then any projected views as well. And then from that, so you can see that once I place these views on here, and I can do an isometric kind of view there as well, and then we can go through and dimension and name them there. And you can see we can set up all of the different options, so whether we want to see the hidden lines or not, we can just move them around. We can also draw center line marks, center marks, patterns, dimensions, so I can go through and just start dimensioning those. And you can see, because it knows it's a cylinder there, that we've got all of the values, like it's put in the diameter symbol in there as well. And then what's going to happen is I'm just going to save this, and I'm going to call it bottom plate drawing. And then if I do go back, and let's throw in again, let's put a fillet on this outside edge here, so 5 millimeters. And in the scheme of things, it looks quite small, but and you can see there's a warning down here. It says we can update the model. So you just need to go through and update them. Oops, there we go. And then that way we can see all of the latest changes. Okay, and you can see here on this view, you can see that the fillet has appeared on the drawing, and you can see here on here that we can, let's see if we can grab that as a radius, and you can see that it tells us that there's a radius 5 fillet on there as well. So again, think of this 3D model as your central source of truth. Okay, and whatever we do to this, our drawings will follow suit and they will update as well. But also as well, don't think of it from just a drawing phase. If you're a Fusion user, you've got the simulation, you've got the manufacturer workspace as well. So if it's something where you're doing CAM, we can generate the tool paths for this if it was something that needed to be utilized for that. So that's for the manufacturing space. For the architectural space, so for any home builders or anyone in sort of the home or building or architectural, anything to do with Revit, and this can be, on the architectural, the structural, or the MEP side of things. This here is just basically a 2D house plan that I brought in, and you can see if I rotate it around, it's completely flat. It was done in AutoCAD. There's nothing special about it, but if you are looking to go from an AutoCAD and you already have these as AutoCAD files, it's quite easy to come in and start basically converting these into 3D. So with Revit, I'm going to place a basic brick wall 230mm thick, and we're constraining the height from level 1, from ground floor to level 1, and my location line is on the exterior of this. So all I need to do is just start tracing around these lines, and then you can see that we can slowly start up building a 3D model of this house. And I'm just going to go through and do a few more points. And you can see I don't need to put any fittings in here. I can just place the walls, because eventually what we're going to do is place all of the windows and the doors separate, which is how you would normally do it inside Revit, and I'll show you that in a second. So what we can do is come out here, and I'm going to finish this wall here, and then I can do the same thing just to finish off the wall. Okay, and then they're in 2D, and even though we've drawn it in 2D, you can't really see it, but if I switch to the 3D view, you can see there's my 3D view of that house. And if I switch it to shaded, you can see there that by default that Revit wall family already had the bricks on it, so you can see all of those bricks there. Now, setting up schedules. So in Revit, there are already some schedules in there, but I've set up a wall schedule. So if I just double click that, then I can see the area of each of those walls, where they are, what kind of family and brick, and what their functionality is. But things like length, and then if we scroll over to the right, we've got a volume in there as well. So again, all of these things, you know, you model it for once, and then you might sort of say that everything after that could be for free, for example. So now let's throw in some windows. So I'm just going to throw in just a couple windows just to demonstrate the ability here. So we've got one in the kitchen, and we'll throw one on this front, and we'll throw a couple here on this living room here, and then I'm going to do the same with the doors. So we're going to throw in a front door, and let's throw one over on the garage. Okay, so now that we've placed them, and I'll switch to 3D view, so you can see there again, they're placed at an arbitrary wall height, but if I decide to change that, if I want that to be 600 high, then you can see it adjusts itself to be 600 high as well, and I can do the same with this one over here. I want it to be 1200, and then there it is. So subsequently, all of the views will change. But before I get into the views, if I look at the door schedule, you can see that it tells me that there are 2 doors, and they're both on the ground floor. And then the same thing for the window schedule. So we do have mark numbers with height, and obviously you can go through and adjust all of those as well. But the real power sort of comes in when we start looking at elevation. So you can see here from the right-hand side, and I'll adjust the views. So you can see automatically the east view, north, south, and west is already created for you. So if we wanted to place these on a sheet, so if someone says, well, I want to see the ground floor plan, then we can place the ground floor plan, and you can see it's there at a scale of 1 to 100 on an A1 AO sheet. So anything we do on this ground floor view will be reflected on the ground floor view on that sheet. And we do have things like turning on and off, whether it's any tags or dimensions, so you can have one view with everything in it, and then each of these sheets will basically, like AutoCAD layers, turn bits and pieces on and off from here, and then subsequently as the model slowly gets built up, then we will have a 3D model, we have our views, and we'll have any sheets and our schedules, all basically, you know, done for free with the click of a button. So don't be too afraid of having a look at Revit if you're a house builder or pertaining to something sort of, I guess, in the architectural industry. And then lastly, I wanted to have a look at advanced steel. So for any steel modelers, steel detailers on the call, Advanced Steel was a product purchased by Autodesk a few years ago now, and then it's obviously made its way into the ecosystem. But this is an example of a structural model that was made into 2D, and then with Advanced Steel, I can basically use this as a base for me to start modeling in 3D. So if I wanted to stick a column on here, I can just come in here and go to the column command, and I can say that it is placed on that in the middle of that point there, and you can see that even though it's not the right size at the moment, it's placed in the middle there. And if I switch to 3D, then I can see that column has come in there. So if I just do the same, if I switch back to my top view, so I can just go do the column command and place it in the mid between 2 points, so I get the center of that column there, and you can see that it's done. And then I can go through and adjust that and say that it is a excuse me, a UC, and that it's a 250 UC. That's a bit big. 200 UC, 150, and there you go. So it's a 37.2. Now, because I don't have to go back and change that one, I can manually, I can go through and do a match properties command. So I can match properties from this one over to that one there as well. And then what I want to do is just show a little bit more on what else we can do with this. So I'm not tracing over a 2D, but I can go from the top of this beam and I can run out, let's make it 3 meters. And I can place it at the top middle of that beam, and I'll do the same thing with the other one. And the reason I wanted to show you this was some of the power with Advanced Steel, and again, this is not only limited to Advanced Steel. The other tools have similar functionality where I can, and I'm going to switch this to conceptual mode, and with my connection vault, I can go through and put a shear plane connection between this column and this beam. Okay, and then Advanced Steel, the macros for it basically let me sort of have all of these grouped in this sort of this intelligent macro that all I need to do is double click on the macro box, and then I can go through and change. So with these horizontal bolts, if I wanted to have 4 in a row, then I can go through and just place it. So I don't have to worry about going back and drafting up and detailing this. And then what I can also do with this is I can group these in sort of a parent and child relationship. So I can copy that over, but now because these two are grouped together, if I go through and change this horizontal bolt back to 2, then you can see this one over here has changed to 2 as well. So again, my productivity has just been boosted by the ability to have these linked together as a parent and child. But let's look at what we can do with once we get into the documentation side of things. So with Advanced Steel, we do the numbering of single parts and assemblies. And then from that, we can start generating assembly drawings automatically. So if I just say, give me all of the MP parts in there, and then I can do the same. So once that's finished, excuse me, what we can do is the same thing for single part drawings. So I can say all single parts. Okay, and then now I can automatically look at the assembly detail for that column, and you can see there that it's got that fin plate. It tells me the holes, we've got the welds, we've got the part numbers, and automatically I know that it's a 225.76 kilo assembly. So from that you can determine what kind of shipping. Okay, and then if we start looking at very similar to Revit, I guess, where if we change the model, it does it a little bit differently, but it's still at the end of the day, the model has been updated, and now the document manager tells me that because of that change, 4 drawings are affected, and I can just say force update. And what that is going to do is update those drawings. And then from here, I can say, show me the assembly detail, and then you can see there that those 4 bolts are automatically put onto the drawing, and you can see that because of that change, it's now at 227 kilos as well. So you don't have to worry about going through and updating the drawings. The only thing you'll need to do is possibly tidy them up with some of the labels or some of the title blocks, but ultimately at the end of the day, it's sort of a one-click function. And then lastly for this as well, so like with Revit, I want to create lists on this as well. So then I can go through and give me a second, and then I can say from these bombs, so let's look at the parts list. So I can say, give me a full material list. Okay, and then there it is. So we can see that we have 2 UCs, we have two flats, and we've got the number of bolts, nuts, and washers as well. So again, because it has been modeled in advanced steel, we don't need to go through and manually do anything. We can just click a button and automatically get a sort of a tonnage report on our advanced steel model. So, and that kind of covers us for the demo. I didn't mention a few sort of things like AutoCAD Electrical and Inventor have linking together. You know, AutoCAD Architecture and Revit, AutoCAD Mechanical and Fusion or Inventor as well. So if you do want a bit of a deeper dive, have a chat to the guys at RedStack, and yeah, I might be able to do a demo for you. So I think that's it, Dexter.
Well, that's it, Ron. Thanks again for joining us in today's webinar. Bye for now.
Thank you.